Hey guys, welcome back to Helper Function. In this video, we will be discussing a popular interview question, maximum subarray. So the problem statement says that given an integer array nums, find the contiguous subarray which has the largest sum and return its sum. And it is also given that we cannot take empty subarray. That is, the subarray must contain at least one number. Now let's talk about this example. If we talk about the whole array, its sum is 0. But if we see this section, that is first 3 elements, its sum is 5. And this is the maximum subarray sum that we can get from this array. Thus, we will return 5 here. So let's see how to solve this. Now the brute force approach to solve this problem would be, we assume that the subarray starts from I. And now for every ith index, we will traverse till the end and update the maximum subarray sum. So looking at this example, let's say I is at the start index. We will take another loop starting from I. We will add this nums of j to our sum variable, which will be initialized to 0. And every time if this sum becomes greater than answer, we will update our answer. But the time complexity of this approach is order of n square, as we are using 2 for loops, and thus it will not work in an interview. Let's see another approach. Let's understand by this example. Say we have 2 variables. One is answer, which will represent our answer and is initialized to minimum integer. And another is the sum variable initialized to 0, which will be the candidate for our answer. Now every time going through the array elements, we will be performing these 3 operations. So at first, we will add nums of I to our sum variable. And now if this sum is greater than answer, then we will update our answer. But if sum is lesser than 0, we will make it to 0. Now let's go through this example for more understanding. So initially we are at index 0, thus we add 2 to our sum. And now because sum is greater than answer, answer will also become 2. And the third condition will not be applicable here as sum is not lesser than 0. Now we are at index 1 and we add minus 3 to sum. Thus sum becomes minus 1. Answer will remain same as it is already greater than sum. But because sum is lesser than 0, condition number 3 will be applicable and sum will become 0. Now this means that the sum of this segment is minus 1, and thus for the next indices, it is better to start with 0 rather than minus 1. Thus whenever our sum will become negative, we will ignore all the previous elements and will start fresh. Now we are at index 2 and we will add 4 to our sum. And because 4 is greater than answer, answer also gets updated to 4. Now in the next step, adding minus 5 to sum will make it minus 1, which will have no effect on answer, but because sum is negative, it will be initialized to 0. And now in the last step, my sum remains 0 and thus answer remains 4. Thus 4 is the maximum subarray sum that we can get from this array. Now let's take another example where every array element is negative. So at first, we will add minus 2 to sum, and because it is greater than minimum integer, my answer will also be minus 2. Now because sum is negative, it's better to start fresh and thus we make it 0. Now in the next step, sum will become minus 3, which will have no effect on answer as it is lesser than answer. But because it is negative, it will again become 0. In the next step, sum will be minus 1, and because it is greater than minus 2, answer will also become minus 1. And again sum will become 0. Now in the last step, sum will become minus 5, which will have no effect on answer, and because sum is negative, it will again become 0. Thus the answer for this array would be minus 1, which is the maximum element in this array. Let's take another example where every array element is positive. So in the first step, sum will become 2 and answer will also become 2. In the next step, both sum and answer will be updated to 5. In the next step, they will become 6. And finally, they will become 11. So if every element in the array is positive, the answer would be sum of all the elements. Thus, we were able to solve this problem in order of n complexity because we are using a single traversal, and the space complexity here is order of 1 as we are using no extra space here. Now let's quickly look at the code. We are given with the nums vector. We take two integers, answer initialized to minimum integer and sum which is initialized to 0. Now in the for loop, every time we will be performing these three operations. First, nums of I will be added to sum, then we update our answer, and if sum is less than 0, then sum will be initialized to 0. And finally, when we come out of this loop, we will return answer as our answer. So this was all about this problem. I put the problem link in the description so you can go and solve it. If any doubts or suggestion, please write in the comment. And if not subscribed to the channel yet, then please do that. Thank you so much for watching.